Welcome back, engineers. Let's continue our discussion on multi-leader replication systems. So in the last video, we saw what is a multi-leader replication system, when do we use it, we compared it with single-leader replication system, and we have seen some protocols and topologies. Now let's see the downside. The main downside of multi-leader system is write conflicts. Because there are multiple leaders accepting the writes, there are going to be conflicts, and we need some kind of mechanism to handle these conflicts. Right? Like I said, this is a hard problem to solve and there is not a straightforward solution to this. We will explore the currently available solutions for handling write conflicts. So first, let's try to understand what are write conflicts. So for that, let's use this diagram. So the timeline goes from left to right, and initially there is a page with ID 123 and title A. Let's say this is the page and it has a title like this, and let's say the title is 123 to begin with. Now in this scenario, user 1 is connected with leader 1 and user 2 is connected with leader 2, and both of them are trying to update the title. So user 1 is trying to change the title to B and user 2 is trying to change the title to C, and both of them have received the OK confirmation from both the leaders. So leader 1 has responded to user 1 saying your write is OK, and user 2 has received update from leader 2 that your write is OK as well. Now both of them have received their writes and they both need to propagate those changes. So both the leaders are sending their own changes to the other leader. Now here is where the conflict is. So leader 1 is sending to leader 2 that change some record with ID 123 from old A to new B. Now this can't be done because title is now C. So from leader 2's point of view, title is now C and it can't be changed from A to B. And similarly, from leader 1's point of view, the title can't be changed from A to C because the title is now B according to leader 1's perspective, right? So this is a conflict. This is how a conflict looks like. Now let's see some of the ways to handle this. So one of the strategies to handle write conflicts is the concept of last write wins. So this is the most simplest of the strategies. We just add a timestamp to every log, and we simply use the update that is having the latest timestamp, and we will override whatever has been written so far and we will simply use the latest timestamp, right? But the downside of this is there is data loss, because if 10 people are trying to update the same thing, only one of them will be retained and 9 of them will be lost, right? So this is a very common strategy and very simple to use, but there is a trade-off that we need to understand. The second approach is weighted leaders, which means we will assign some priority to the leaders, and one of the leaders will have the highest priority. So if there are multiple writes coming in, the write coming to the leader of the highest priority will be retained. All the others will be discarded, right? So this is one of the other strategies. The third one is to merge the values. So instead of overwriting one or the other, just merge them, use both of the values. So in the case of our title example, if the title is changed from A to B from one leader and B to C from other leader, we will merge them and give out something like this, B/C, right? So both of the values will be shown to the user, and user can decide what to do with that, and there is no data loss. So that is the advantage of this, no data loss. Now let's look at some of the strategies which we can employ at code level. So the first thing is to use automatic resolution, which means we will use some kind of algorithm to automatically resolve the conflict. And the other is to use prompt user technique. So this is something you must have seen in Git. When two files are getting merged and there are some conflicts, Git does not allow you to merge them, but it shows that there are conflicts, and it is up to the developer to resolve those conflicts manually or automatically and then try to merge the files, right? So this is prompting user. But to do it automatically, we can use a couple of options. The first is CRDT. This is conflict-free replicated data type. And this is one of those modern techniques which is used to handle write conflicts. And we will try to go deeper into this CRDT in a future video. But for now, let's try to understand that it uses some kind of counters for every leader and keeps track of these counters, and whenever there is a conflict, it is trying to use those counters to make some kind of convergence, and all leaders can be converged into the same state. So that is the idea behind CRDT. Another technique is operational transformation. This is also widely used for collaborative editing. And the idea is to change the order of the operation so that eventually when all the operations are completed, all the leaders will be in the same state, right? So we can think of these as a couple of algorithms or techniques that are widely used for handling RAID conflicts. We will try to go deeper into them in a future video, right? Now let's see some example databases. So CouchDB and Cassandra are a couple of example databases where we can see the multi-leader replication. And when do we use this multi-leader replication? We have already discussed this before. Whenever we are okay with eventual consistency, we can make use of this concept of multi-leader replication so that we can avail the benefits of the system. For example, social media posts. So if I am making a post and it reaches you eventually, maybe after a couple of seconds or couple of minutes, that is still okay. That is not so critical that you receive the update in real time, right? And also maybe apps like calendar where we can support offline sync, right? So I can use my phone to update the calendar. I can make new events, and when I'm online again, the events will get synced, and there is some kind of conflict resolution involved, and eventually my data is up to date. And we can also use this for collaborative editing apps like Google Docs, right? So this is all we need to know about multi-leader replication systems. So if you have any questions, definitely put them in the comment below so that we can explore it further. Thank you so much for watching, guys. In the next video, we will look at leaderless replication. So definitely subscribe if you haven't done already so that you don't miss out on the future video. Do leave a like if you found this helpful. I'll see you in the next video. Thank you so much for watching. Cheers.